So now, as we have a good picture of how the plant shall look like, and we know its main requirements, we can start the detailed engineering phase. In many cases, the company that carried out basic engineering is different from the one that shall continue with the project and carry out the detailed engineering. This is common, especially in projects that have some license or proprietary technology. That's why the handover between the two companies should be done carefully. This can be done through the field verification stage, where the detailed engineering company carries out a thorough verification activity on the field documents and highlights its concerns. These concerns are usually essential to reserve their rights afterward or to consider a greater project budget. After field verification is carried out, we shall start detailed engineering. During detailed engineering phase, we are supposed to address the main issues that were left open during the basic engineering. So we should add all the data for piping and instrumentation. For example, in the field P&IDs, there may have been some pipe sizes that were not added, like the case of utility or effluent or relief lines. So during this phase, we should add all these details. We should also add the details of control and shutdown loops, the main signals and indications in the DCS, alarms, and any shutdown actions needed that were not added during the feed stage. We should also add the PSV sizing details. In addition, there may be some issues that were not closed during the feed or that were discovered during feed verification. It's time to close these issues and reach a resolution with the client or the operation team regarding these points. We shall start to receive concerns from other disciplines. For example, the piping team is now preparing much more accurate 3D model for the plant. So some clashes are identified, some piping routing may be changed, some issues may arise. So here we may change some pipe sizes or provide some solutions based on these issues. Remember that all these may also affect plant hydraulics, and the plant hydraulics may cause changes in pipe sizes. So these changes should also be reflected on the P&IDs. We may see that some instrument types may not fit for purpose or they need more details to be shown on the P&ID in order to perform well. So we shall update the P&ID to add these requirements. We should also receive the feedback from different vendors. This feedback can also lead to changes. For example, the pump vendor may supply curves that require shut-off pressure, which is higher than that of the equipment or piping on the pump discharge. This shall mean that we should either increase the design pressure of the discharge system or add protection to avoid overpressure, such as a pressure safety valve or a shutdown protection at high pressure. We can also just add more enhancements to the design depending on the situation that we have, as long as they won't cause a drastic change that may have impact on the cost or the duration of our project. Now, based on the above, we can issue the next P&ID for design.